So here's a look at the 3000 watt inverter that I put in the back seat of my F450, and here's a look at the wiring that I've installed on the truck. We have a 400 amp mega fuse on 40 wire. That's pure copper welding wire covered in convolute running all the way to the back seat. And the question is, how does this system compare to the new 2 kilowatt system that Super Duties in 2023 are going to have available? Some of the benefits of our aftermarket system compared to what Ford's new factory system is going to be is we have the ability to turn this on with the engine off. And if you're going to run a small load for a short period of time, the batteries can sustain just running something small like a laptop charger for a temporary period. I mean, 10 minutes or 15 minutes or whatever, if you just need to turn the engine off. Not a big deal to just have this running for a second. Another benefit is the fact that even with this system that we have here, we have a 3000 watt system with a 6000 watt surge. So that's 3000 continuous, 6000 startup surge. Like when you plug in a big air compressor and that initial push to get everything moving and everything running, maybe that load that's on there just to get it started is where that extra surge power comes into play. Now with the factory Ford system, we don't know if their new system is going to be a 2000 watt continuous with a 4000 watt surge, or is it going to be a 1000 watt continuous with a 2000 watt surge, and they're advertising the 2000 watt surge as their power available. Hopefully it's a 2000 watt continuous 4000 watt surge. Now with their old style that we have, this is the factory inverter with the truck, it's only a 4000 watt max. So that means it doesn't have an 800 watt surge. It really is comfortable at a 200 watt usage. So our laptop computer, this thing will not continually charge our little laptop computer. It also won't run one of these 400 watt Milwaukee chargers. It will run a small battery on here, but it won't run the big 12 amp batteries that we have. So with all that being said, one of the critiques that I've gotten about my system is, man, that wire is too thick. Why is that wire so thick? Why you're running 40 wires, too heavy, all that stuff. Well, it all comes down to that 600 watt surge that our 3000 watt inverter can put out. So the challenge with going from a 12 volt system to 120 volt, the speed of the 12 volt electrons are going to have to be accelerated to the speed of 120 volts. So it's much faster. You need the heavier gauge wiring on the 12 volt side. But once you get to the 120 volt AC current side, you don't need thick wiring to run big equipment. Think extension cord. You can run on a 120 volt AC circuit, you could run a 100-foot extension cord. On a 12 volt circuit, you couldn't do that. There's a lot more limitations to running distances on 12 volt systems and wire size on 12 volt systems. And ultimately, that is why the world runs on AC 120 volt, because it can run these long distances, and the amount of copper that it would take to run on a 12 volt system, although I can reach in here right now and touch both of these leads and not be electrocuted and not die and not have any problem. I could just touch these, no issues. But we're not running enough speed and everything to run big equipment. That's why your household outlets are so much more useful, and it's useful to have these inside of your truck, because now you can actually run a job site. I could put an extension cord on this 3000 watt inverter, idle the truck, and run chop saws, air compressors, everything, as long as I'm within that 3000 watts. For example, this big air compressor can run an entire job site, and it uses about like 1200 watts of power to run. And it takes 400 watts to charge one of these big 12 amp hour Milwaukee batteries, and you can run a job site with a handful of these. So if you have 4 of these charging, not a problem for a 3000 watt inverter. So with all that said about the 12 volt system, if this was a 48 volt system, all this wiring could be thinner. If this was a 24 volt system, all this wiring could be thinner. But the higher the voltage, the thinner of the wire you can get away with. But unfortunately, for our sake, vehicles run on 12 volts. So the wiring needs to be heavy in order to run the vehicle on the 12 volts. If we were at 24 volts, could use thinner wire. Now, what is the challenge for a company like Ford to put 2,000 watts or anything like that in a truck? Well, the problem and the issue is the wiring size. If they're going to run 12 volts to that system, then it's challenging to run the wiring. Now, if they could step the voltage up with some kind of a device that can change the voltage, if they could step the voltage up to like 24 volts or 48 volts just to make that run back, then it would be a lot easier for the system to run higher voltage inverters. But the inverters themselves, they don't cost that much. Hold on, I got a call. So the challenge for the OEM is, how do you power such a large inverter on a 12 volt system as the wiring gets thinner? It needs to be thicker and thicker as the system changes. Now, for the power boost, they already have access to higher voltage systems because it's a hybrid truck, so they can run the big 7.2 kilowatt inverter based off of the charging system that's already in the truck. But for the OEM, it's a matter of how do they position the inverter as close to the 12 volt source as possible, because as the inverter is closer to the 12 volt system, the thinner the wire can be. And then how do they make a determination on the maximum amount of voltage they want to run based on the amount of copper? Because when you're the OEM, you can't just get 4/0 wire copper, whatever thickness copper. All that stuff adds up per unit. One of the most expensive parts of this whole install was just the copper wiring. But that's where the challenge is. So what do you guys think? What do you guys think about this aftermarket solution for power? I've used this thing so much, mainly for charging my laptop and everything, but it's nice to be able to charge 5 Milwaukee batteries if I wanted to, or an air compressor. I've ran that thing on this. But whatever you might want to run, I mean, you could idle the truck overnight and run your house in a power outage if you had to. Instead of just losing all your food and groceries and just not having any power, this thing could power your whole house. Now, the diesels idle pretty efficiently because on a normal gasoline engine like what we have here, say you're going to idle this thing, it has to run at a lean rich threshold of roughly 14.7 parts air to 1 part of fuel. So it has a set determination of how much fuel it's going to burn, being a support injected engine. If it were a direct injected engine, it could idle much more efficiently because the fuel is injected directly into the cylinder. The lean rich threshold of air to fuel ratio could be anywhere from like 40 to 1, 40 parts air, 1 part fuel, instead of just having it being 14.7 parts of air to 1 part of fuel. So a direct injected engine can idle much more efficiently than a port injected engine. But our diesels, our 6.7 Power Stroke, is a direct injected engine, so it really just sips fuel at idle. It just sips it ever so slowly at idle. And even if you kick the truck into a higher idle, which is what you'd have to do, because it wouldn't be generating enough heat to actually be good for the engine. If you're going to idle this thing for a long period of time and just have it at base idle, it's not good for the cylinders. You really want to do a high idle to kick up those RPMs and kick up that oil pressure a little bit, and get that cylinder pressure up high enough, because these engines run on compression. They ignite off of compression, so you need a little high idle. But nonetheless, it wouldn't be the worst thing in the world to high idle this thing overnight in an emergency to power your home. Ultimately, the best solution would be a freaking power boost, because it don't even really run the whole time when you have a power boost. It has the ability to turn on and turn off based on the available power in the battery, and then they give you that big hybrid battery that will hold the power output for a good while. With that power boost, I even ran that compressor that I showed you earlier, and it didn't even kick on most of the time. It just ran off the battery. Speaking of power boost, my old lady just pulled up with our power boost. There it is. With her goofy backup chime. And there is her Pro Power right here in the back. And I believe you can press this button and get access. Let's see here. Yeah, there it is. It lit up for us. Pretty bad, eh? You even get the big plug. But that's it for today's video. My name is Sean. This is DS Trucks. I'm just spending a little bit of time with the 450 as I prepare for it to leave. But anyway, see you guys in the next video. Over and out.